right, welcome to the slope lesson. If I was designing a textbook, I might have begun here, but here we are in 3.5 talking about it now. Slope is the ratio of vertical change to horizontal change. It is the change in y over the change in x. Please note if you printed the notes, I just noticed I accidentally had swapped those, so I paused the video, swapped them back out, but I cannot resend the PDF because I've written all over these slides now. It's also rise over run, and we also have a nice little formula for slope. So if we have 2 points and we want to calculate the slope, we call them point 1 by putting little subscripts in with a 1 and a 1. And we just assign the other point to be point 2. Doesn't really matter which one is which. And we plug it into this formula here, y2 minus y1 over x2 minus x1. And you can see why I didn't type that. Probably could have imported something from online. Note to self. But there is the slope formula. All right, there's a couple different ways slope can look, and if you've seen me graphing lines this whole chapter, you've probably already come across all of these. We can have a positive slope. I'll go back and write in these in just a second. We can have a slope that's slanting downward, because typically we read from left to right, so if you look at that line, it looks to us like it is slanting down. We can have a flat line, and we say that has no slope, or we can have a vertical line and we say this slope is undefined. And so here, this is an example of positive. This is an example of negative. This is no slope or zero slope. And then if it's vertical, we say it is undefined. So, graphically, this is what it looks like. Let's practice a few where we plug it into the actual slope formula. So, just designate one of them as being your x1, y1. And the other point is your x2, y2. Y's always go on the top. So you're going to have 11 minus 3. Notice how there are built-in negatives to the formula. You're subtracting. You saw me do that with the rates of change as well. I always subtracted because you're looking at how it differed. And then 4 goes first on the bottom. Take away 2. So we have 8 over 2, which reduces to 4. If we're graphing, sometimes it's nice if we write that as 4 over 1. Let's do this, x1, y1, x2, y2. So we're going to start, watch your negatives. We're going to start with a negative 7 minus a 1. And then here we have 1 minus, and then our x1 value is a negative. So I would just encourage you to write everything out. Negative 7 take away, another 1 is negative 8. 1 minus a minus 3, that changes those to a 4. So here your slope would be negative 2. x1, y1, x2, y2. So 4 minus 4 is 0. This is an example of 0 slope. 6 minus 2 is 4. So this would be a horizontal line, and it would have a slope of 0. You don't always have to write out the word 0. I just do because that way it just makes that clear. All right, if you want to try one, I gave you one to try right here. So x1, y1, x2, y2, 11 minus 3, over -6. Watch your negatives. Minus from the formula, and then your coordinate is a -2. So 8. Interesting, I randomly picked this the same as before. And then that's going to go like that. And so -6 plus 2 is -4. And so 8 divided by -4 is a -2. So often I could pick any points in the world, and once my head gets stuck in on a point, sometimes it comes up over and over and over again. All right, let's graph some of these lines. Let's make it easy for you. Let's put 1 point here at -3. And let's put another point here at 7. And so if you want to draw that, and that way you know exactly where that crosses. All right, you can just count out. The reason it's called rise over run is that you can count out the up and down. The rise refers to whether it's going up or down, and the run is referring to whether or not it's going right or left. So you can certainly write down the points. One of those points was -3, the other one was 0,7, and plug it into the formula. Or you can just count the way we were counting on that rate, 3.5. So we went 2, 3, 4, 5, 6 there. Oh, I must only be up 6. 1, 2, 3, 4, 5, 6. All right, well, I told you 7, so I'll change mine to match. 7, and I'll change my old lady eyes here. So up 7, and then I go right 3. Both of those directions are positive. You can tell by looking at my line that it looks like it's slanting up. It should be positive. So you can use that as kind of a self-check. Your slope here would be 7/3. Up 7, right 3. Let's look at another one. I want to do one that's vertical, so let's put in a few dots right there. This is the dot. Let's double check my counting here. I think it's for 1. 1, 2, 3, 4, up 1. And then 4, this is going to be 7 this time. This is an example of a vertical line. So we know that slope should be undefined. And so I do want to show you why that is. Let's plug this last one just into the slope formula real quick. I'm going to subtract my y's, and I'm going to subtract my x's. And notice here, 7 take away 1 is 6. But 4 minus 4, I end up with a 0 on the bottom because my x's subtracted out. And so I just wanted you to make that connection, that is why that is undefined. All right. Last example here. I don't know if it came across in the video, the bell for my school day just begun. So a mountain rises 750 feet over a horizontal distance of 900 feet. Find the slope. You're going to see applications in this lesson as well, even though we just did that in the previous lesson. You're not going to notice it so much on MyMathLab, but this is the way the book is. So rise over run, rise up and down, horizontal distance. So we have this run. So we're going to put 700 feet over 900 feet. And so we can reduce that fraction and write it as or we can reduce and write it as a fraction. We can write it as a decimal. 75 over 90. 75 is going to be 15 over 18, taking a 5 out. I can still take out a 3. It looks like it's going to be 5 over 6. So there would be my slope. It's a 5/6 slope. And there are no units like rates because those units cross out. So this would be my slope, 5 over 6. All right, so that is the lesson that maybe you've been waiting for or you watched first to kind of connect all the dots. And we only have one lesson remaining for this chapter, and it's got quite a bit in it. Section 3.6 does have a lot of different examples, so make sure you carve out some time to go through all of those. Take care, everybody.